All right, here we're going to look at section 7.5. And our learning targets for this section are to solve rational equations by cross-multiplying. Second one is solve rational equations by using the least common denominator. And then our third one's going to be using inverse functions. So let's look here. So I see here I've got one rational expression on the left and one rational expression on the right. And when I see those things, I don't have more than one on each side. I can cross multiply. So just like we did with simple fractions before, when I was trying to find a missing piece, I would just cross multiply and then solve for my variable. We're going to be doing the same thing here. It's just a little bit more complicated. So I go ahead and I cross multiply. So I end up with 3 times the quantity 4x plus 5 equals 9 times the quantity x plus 1. So I multiply each numerator by the opposing denominator, and that's equal between them. So now that I have this set up like this, I can just use my distributive property and simplify it a little bit further. So 3 times 4x is 12x, 3 times 5 is 15, equals 9 times x is 9x, and 9 times 1 is 9. So now I just have a linear equation, so now I can solve for my x. So I'm going to get all of my x's on one side, so I end up with 3x plus 15 equals 9. Now get everything else to the other side, so I subtract 15 from both sides, so 3x equals a negative 6, and I go ahead and I divide by that 3, so my x equals a negative 2. So just like before, I always want to check my work, but when I'm dealing with rational functions and rational expressions, I always want to make sure that my denominator is not going to be 0. So I look back up in my original equation and see if there's anywhere where this x equals negative 2 would make my denominator 0, which would make it not a real answer. And I don't see that that's the case here, so I know that this is my answer and my solution. So now let's look at kind of a word problem and see what we can do here. So an alloy is formed by mixing 2 or more metals. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. If I have 15 ounces of 800 grade silver, which is 80% silver and 20% copper by weight, how much pure silver should I mix with the 800 grade to make sterling silver? So I want to look at what I have and what I'm trying to find. So I know that I'm going to be dealing with the percent of the copper in the mixture that I want to have is equal to the weight of the copper in the mixture divided by the total weight. So I know that the percent that I want to end up with is this 7.5. And again, I don't like dealing with percentages, so I'm going to just write that over 100. I can, right, have 0.075. If I take this and I move my decimal 2 places, it's the same thing. However, when I cross multiply, it will be easier if it's written this way. So then I set it up. I've got this 0.02, which is my 20% of what I already have in this 15 ounces. So this tells me how much copper I already have, because 20% of this 15 ounces is copper. Then in my denominator, I know I have the 15 ounces that I start with, and I'm trying to figure out how much silver I need to add. So now that I have this, I can see I have a rational expression on the left and a rational expression on the right, so I can go ahead and cross multiply. So my 7.5 times the quantity, 15 plus x, and my 100 times my quantity up here in the numerator. So then I just simplify. I distribute this 7.5 and I go ahead and multiply. Now again, I see I'm left with a linear expression or equation, so now I can just get x by itself. So I subtract my 112.5 from both sides, and then I'm going to divide by my 7.5. So I know that my x would equal 25. So I'm almost done. I always want to finish with what I mean. I don't care what x means. Tell me, what does it mean? So it means I should mix 25 ounces of pure silver with my 15 ounces of 800 grade silver. Right? So I've used my problem to explain what my answer means, and I always want to do that. So here are some that you can practice. You'll see that there's one expression on each side of the equal sign, so we can use our cross multiplication here. So now I see I don't have one expression on both sides, so what do? There has to be a different way to solve this. So the first thing I do is I find my lowest common denominator, right? My LCD. Let me rewrite that. That didn't work out well. So I want my lowest common denominator, right? So I can multiply the things together in my denominator. Look back at 7.4 to find our least common multiple, right? Same sort of thing. So I see that for this part A, it's going to be 4x. So I'm just going to rewrite my equation a little bit larger. equals a negative 9 over x. So now that I've found that my lowest common denominator is 4x for this, I'm going to multiply both sides of the equation by 4x. Okay, so when I multiply that out, I end up with 4x times 5 divided by x plus 7 times 4x divided by 4 equals a negative 9 times 4x divided by x. Okay, so now I see I have some similarities in the numerator and the denominator that can cancel out, right? So I see I have x divided by x, which gives me 1. Here I have 4 divided by 4, which gives me 1. And again, I have an x divided by x, which gives me 1. So now I'm left with 4 times 5 plus 7 times x equals negative 9 times 4. So I've successfully gotten rid of my denominators. So now I can just simplify, so I end up with 20 plus 7x equals a negative 36. So I subtract my 20. So 7x equals a negative 56. So I know that x equals a negative 8. So I can always just double check and make sure that my work is correct by plugging it back in and trying it out. So now let's look at part B, where I've got 1 minus 8 over the quantity x minus 5 equals 3 over x. So I first want to find my lowest common denominator. And since I don't see anything common here, I'm going to go ahead and multiply them together. So my lowest common denominator is going to be x times x minus 5. So now that that happens, now that I know that, I'm going to multiply both sides times that least common denominator, right, times x minus 5. And I can multiply them through. So now I'm going to end up with x times x minus 5 minus 8 times x minus 5 divided by x minus 5 equals 3 times x minus 5 divided by x. So now again I see I have those similarities that I can cancel out. So I know that x minus 5 divided by x minus 5 is 1, and I know that x divided by x is 1. So now I know that I'm left with my x times x minus 5 minus 8x equals 3 times x minus 5. Now that I've gotten rid of my denominator and any weird other terms, I can go ahead and distribute. So x squared minus 5x minus 8x equals 3x minus 15. So now I see I'm going to have a quadratic, so I want to get everything to one side so I can solve. So I end up with my x squared. Negative 5x minus 8x is a negative 13, 14, 15, 16, so minus 16x plus 15 equals 0. So now that I'm here, I can go ahead and factor this out. So I want to find all of my factors of 15. So it can either be 1 times 15, or negative 1 times a negative 15, or 3 times 5, or a negative 3 times a negative 5. Now I'm going to find the sums of these. So I know that that equals 16. It's a negative 16, 8, and negative 8. So I just added my factors together, and I know I'm looking for this negative 16, so here's what I'm going to use. So I will end up with x minus 1 times x minus 15. So now that I have it factored, I use my zero product property, so x minus 1 equals 0, and x minus 15 equals 0. So I end up with x equals 1 and x equals 15. So both are possible solutions, and I want to go double check that I don't have any that don't work. So I go back to my original equation to see if anywhere my x value will make my denominator 0, which it won't, because I have 1 and 15, and both of those end up working. So both of these will end up being solutions for this problem right here, my x equals 1 and x equals 15. So you'll see the only difference that we did here is I have more than one rational expression on one of the sides of the equation, so I can't just cross multiply. I have to use the lowest common denominator. So now here are some more that I want you to practice with. So now let's look at this one, because this one's a little bit bigger, right? So I see here in the denominator, I can go ahead and factor a little bit. So I know I have x plus 3 and I have x minus 3. So here I see that my other two denominators are already included in this one, so this right here will be my lowest common denominator. So let's go ahead and multiply everything times that. So I end up with my 6 times x plus 3 times x minus 3 over x minus 3 equals 8x squared times my x plus 3 times my x minus 3 over my x plus 3 and my x minus 3 minus 4x times x plus 3, x minus 3 over x plus 3. So now I can go ahead and simplify the things that multiply out, right? Because x minus 3 divided by x minus 3 is 1. Same thing here. I can get rid of a few things. So now that we're here, let's go ahead and simplify. So I end up with 6 times the quantity x plus 3 equals 8x squared minus 4x times the quantity x minus 3. So now that I'm here, I can go ahead and distribute. So I end up with 6x plus 18 equals 8x squared minus 4x squared plus 12x. Now I see I'm going to have a quadratic, so I want to make sure everything gets to one side. 6x minus 18. So I end up with my 8x squared minus 4x squared gives me 4x squared. 12x minus 6x is plus 6x minus 18. So I notice that I can factor a 2 out of everything, right? And this is all now equal to 0 because I moved everything over. So I have 2x squared plus 3x minus 9. So I need to factor. And if you need to review factoring, please do that because we're going to be continuing to do that often. So I know I can go ahead and get rid of this 2 because to get rid of this 2, I just divide both sides by 2, and 0 divided by 2 is still 0. So I can go ahead and factor this. So I know that one of my first terms will be 2x and the other will be x. So I know that all of the ways I can make a negative 9 are a positive 1 and negative 9, or a negative 1 and positive 9, or a negative 3 and positive 3. So I'm going to go ahead and try the 3's. Okay, and I know one has to be positive and one has to be negative. So let's just see if this works out. So 2x times x is at 2x squared. So then I have a positive 6x because 2x times 3 is a positive 6x. And here's my negative 3x. So that gets me a positive 3x for my middle term. And negative 3 times positive 3 is a negative 9. So I've factored correctly. So now I'm going to set each piece equal to 0 and solve for each piece. So I know that my x equals 3 over 2, and here x equals negative 3. So again, I want to go back to my original equation and check what I have. So I know that one of my solutions was x equals negative 3, and I also have 3 over 2. So I see if I put in this negative 3 right here, for this x, I will end up with a denominator of 0, which we can't have. So I know that this is called an extraneous solution, and it doesn't work. So this only has one possible solution, which is right here. And I know that because if I plug this in for x down in the denominators, it does not give me a 0 in any place. So I know that it works for sure. So here's a couple more that I want you to try and see how you do. So now we're looking at that third learning target, finding inverse functions. So here's my function, f of x equals 2 over the quantity x plus 3. So I need to determine whether the inverse is a function and then find the inverse. So the first thing I do is I graph my function, and I do see that it is, the inverse will be a function. So then I can find the inverse. So I start with y equals 2 over x plus 3. And remember, the first step I ever do when I'm finding the inverse is I switch my x and my y. So now I see I have one rational expression on the left and one rational expression on the right. So I can go ahead and I can cross multiply. So 2 equals x times the quantity y plus 3. Well, I know I'm getting y by itself, so I'm going to go ahead and I divide by x, which leaves me with y plus 3 on the right side. So now to get this y by itself, I subtract 3, so I end up with 2 over x minus 3 equals y. So this right here would be the inverse of this function that's given up here. So all I do again is switch my x and my y and then solve for y. And here when I do that, I just end up with a rational equation, and so I can use cross multiplication to get that y by itself. So here let's look at one more example. So back in 7.2 we wrote this function c equals 50m plus 1000 divided by m, which represents the average cost in dollars of making models using a 3D printer. So I want to find out how many models must be printed for the average cost to fall to $90 by first solving the equation, then using the inverse of the function. So the first thing I want to do is I want my average cost to be 90. So I set that for C, and then I solve by cross multiplication because I have one rational expression on the left and one rational expression on the right. So I write it out. I end up with 90 times m equals 50m plus 1,000. So then I can just subtract my 50m from both sides and divide. So my m would have to be 25. So now I want to solve my equation for m. So I want to leave C there. So I want to get m by itself. So this ends up being, since I'm dealing with a fraction, I can rewrite this as 50m divided by m plus 1,000 divided by m, right? I'm just breaking my fraction apart. So then I notice that I've got an m divided by m, so it simplifies just a little bit. So that's where we get this at. So now I can subtract my 50 from both sides. I can cross multiply and get m by itself. So if I multiply both sides by m and then divide both sides by the c minus 50, I've solved for that m. So now, again, I can solve it this way as well. So again, when c equals 90, I just plug that in and find my m, and I end up with the same answer. So my average cost will fall to $90 per model after 25 models are printed. So there's two different ways I can do this, right? I just simply substitute it. And then the second way is I found the inverse of that function, and then I plugged the number in. So let's look back at our learning targets and see how we did. Okay, so our first one was solve rational equations by cross multiplying. So we know we can cross multiply when I have one rational expression on the left and one rational expression on the right. If I have more than that on either side, I have to use a second learning target, which is solve rational equations by using the least common denominator. And then there are going to be times when it's easier to find the inverse function first, and then I can plug in and find some information. So I need to know how to do that as well. So now I want you to go ahead and work on that homework for 7.5.